Ladies and gentlemen, good evening. This is Jeremy Norvan, and today I decided to make a video about the Vector Autoregressive Model, also known as the VAR. So the reason why I decided to make this video is because it is very important to know how to use the Vector Autoregressive Model, specifically if you work in economics, finance, history, and political science, because the VAR is used pretty much to analyze and forecast many outcome variables at the same time. So one thing I want you guys to understand is that the VAR is one of the most complicated statistical models that is usually used in econometrics. So the way I'm going to proceed is that I'm going to use a unconventional route, but the purpose is for you guys to fully understand the mechanism of the model so that you guys will know how to use it extensively. So I'm going to start from the basics, moving to the more advanced part. So the Vector Autoregressive Model, in fact, was developed by Christopher Sims. So for those who follow me on Instagram, Christopher Sims won the Nobel Prize in 2011 in economics for developing the VAR model. So Nobel Prize 2011. So he developed the VAR, the Vector Autoregressive Model, and he earned the prize for that. But before we actually dig into the Vector Autoregressive Model, I'm going to do a review of the multivariate, and you will understand why I'm doing this review. Because the purpose of this review is to establish a correlation between the Vector Autoregressive Model and the multivariate regression. All right. So, a couple of videos ago, I think it was 2 or 3 videos ago, I said that the multivariate regression was different than the multiple linear regression model. In fact, the multivariate regression is a system of equations. That contains at least 2 outcome variables and depends at least on one predictor or more. So the multivariate regression can be a system of equations of many simple linear regressions, or it could be a system of equations of many multiple linear regressions. So I'm going to show you an example of each, so that you will see exactly how the multivariate regression is designed. So let us do the multivariate with one predictor, also known as the SLR for simple linear regression. So you usually have Y1 and Y2. So every time you start dealing with the multivariate, always start with the fact that you have 2 outcome variables, always. So you have Y1 and Y2, and then you have beta 01 plus beta 11 x1 plus the standard error 1 or epsilon 1, beta 02 plus beta 21 x1 plus epsilon 2. So here you see that the notation is a little different. And the reason why it's different is because since we're dealing with two outcome variables, we have to make sure to distinguish them properly so we know what we're dealing with. So the beta 01, so you see beta 01 and beta 02. So the beta 01, so the 0 stands for the fixed parameter, which is also the intercept, as we know. The one that follows the 0 means that it is the intercept for the first outcome variable. And we can come back for the second equation here. The 0 is the intercept, and the 2 that follows the 0 means that it is the intercept for the second outcome variable. All right, that is clear. Now we have beta 11. What beta 11 means? So the one that comes after the beta, so the first one of the 11 means that it is the coefficient of the first outcome variable. And the second one here that I put in green means that the coefficient is for is based on one predictor. That's why you have beta 11. And then of course epsilon 1 because it is the standard error for the first outcome variable. If we move to the second equation, the same process. You have beta 21. The 2 means that it is the coefficient for the second outcome variable. And the 1 that follows the 2, I'm going to put it in green here, means that the coefficient depends on this predictor, on one predictor, which is x1. That's why you have beta 11 and beta 21. That being said, we have here the multivariate regression just based on one predictor. Now let's do the multivariate with 2 or more predictors, which is basically a system of equations based on the multiple linear regression. We say multiple linear regression because we have a system of equations that have at least 2 or more predictors. So we have here y1 and y2. Always, when you deal with multivariate regression, never forget you have y1 and y2. y1, y2, so we follow the same process, beta 01, beta 02, plus beta 11 times x1, beta 21 times x1, plus beta 12 times x2, plus beta 22 times x2, plus epsilon 1 plus epsilon 2. So here, if you guys follow carefully, you can see the logic here. So you have beta 12 and beta 22. So of course, the 1 in the 12 means that it is the coefficient of the coefficient is based on, of course, the first outcome variable, and the 2 that follows the 1 in the beta 12 means that the coefficient depends on this predictor here. So the 2 here means that it depends on this predictor. So the same logic applies for the second equation. So the first 2 means that it is the coefficient of the second outcome variable, and then the second 2 that comes here means that it is it means that the coefficient depends on the second predictor. That's why you have beta 22. So beta 12 and beta 22. So that being said, now we have done a brief review of the multiple of the multivariate with two variables. I say more, I put more, but I didn't go with the accent. But you guys know that it's basically a system of equations of multiple linear regressions, because they have at least two predictors. All right, now I'm going to move to the vector autoregressive model, and you guys will see the link between the multivariate regression and the vector autoregression. All right, so I start with VAR. So the typical, or should I say the conventional way to write the basic model of the vector autoregressive model is the following. You have y1t and y2t. And the reason you have t is because we are dealing with time series data. The multivariate only deals with either cross-sectional data or panel data. And the specificity of the multivariate regression is that it has to be linear. Whereas when you deal with time series data, when you deal with regression in time series data, for the autoregressive model or the VAR model, it has to be stationary. So the VAR, in fact, is an extension of the AR. So the AR means the autoregressive model. So we know that the autoregressive model is usually written like this: beta 0 plus beta 1 y1 t minus 1 plus epsilon t. So this is the typical model for the autoregressive model. Since we're dealing with the VAR, we have more than one outcome variable. So the VAR is a multivariate form of regression for time series. That's what the VAR is. That's why I started with the multivariate regression, so that you guys will see the link. All right. So back now to write the model mathematically. So we have y1t and y2t. It's because the VAR goes from the principle of the autoregressive model, which we use the previous values of the output variable, and we're trying to predict or to forecast the future value of that same output variable. And that being said, since we're dealing with two outcome variables at least, we're going to run the model as the following: beta 0, 1, beta 0, 2, plus beta 11, y t, y1 t minus 1, beta 21, y 1 t minus 1, plus, I hope you guys follow me here, beta 12, y2 t minus 1, beta 22, y2 t minus 1, plus epsilon 1 t plus epsilon 2 t. All right, you're like, oh my god, what is this? This is the VAR model, the basic form of the VAR model. So you have here beta 11 and beta 12. It's because the two outcome variables here are linked. That's why. they depend on one another. In fact, the second outcome variable has an endogenous effect on the first outcome variable. So if I can do a quick design here, you guys will see. So let's say you're selling apple. So apple is your Y1T, and apple and oranges are your Y2T. So the Y1T means this is at the current time you're selling the apples, okay? And the Y2T means that it's the current time at which you're selling the oranges. So when you have Y1T minus 1, it means this is the value of the apple that you sold last month, last week, or last year, whatever the time you're using. But it's the previous value of that apple, of that apple you sold. And then for Y2, which is the oranges, you also have Y2T minus 1. So you wonder how the sales of, how the sales of the apples last month affect the sales of the oranges today, and how the sales of the oranges last month affect the sales of apples today. That's why we have this. That's why you have Y1T minus 1 and Y2T minus 1 in the same equation, because there's a form of interdependence between the two outcome variables. That's why you have this form of equation. So now that this is clear, I'm going to write the VAR model into a matrix form, because every time you deal with multivariate form of regressions, you have to write into a matrix form. And the reason you have to write into a matrix form is in order to write a compact mathematical model of the regression. That being said, we're going to have here Y1T, Y2T equal. So we're going to basically put every variable, or should I say every number, with their own groups. So Y1T, Y2T goes here. See? And then you have beta 01, beta 02. So these are the fixed parameters. They go into their own column of the matrix. Plus, then you write beta 11, beta 12, beta 21, beta 22. They go in their own row and column, in their own matrix, should I say. Then you have here Y1 T minus 1, Y2 T minus 1, plus, then you write here the error terms together. Okay, now if you even want to verify, we can verify this. So Y1T minus 1 times beta 11, this is what you have here. Y1T minus 1 times beta 21, this is what you have here. Y2T minus 1 times 12 times beta 12, that's what you have here. Y2T minus 1 times beta 22, that's what you have here. So it's pretty simple, as you can see. So what form is it going to give us? It's going to give us the following. So the Y1T and Y2T, which are basically the fruits, we can put it fruit if we want, but we're going to put a big Y. So we're going to say here YT. equal, let me put it a little up here. So let's write this here. So it's going to give this. So it's the matrix form we're writing, right? So it's going to give yt equals, so the fixed parameters we can simply put a big beta, so beta t plus beta yt minus 1 plus epsilon t. Why we have only t minus 1? Because at the end of the day, we're simply moving one lag in the past. We're only moving one lag in the past, so that's why we only have yt minus 1. Whether it's y1 t minus 1, y2 t minus 1, y2 3 minus, it doesn't matter. But we're only moving one lag in the past. So at the end of the day, this equation here, this model here shows that the VAR model that we're dealing with, it's called the VAR 1. It means Vector Autoregressive 1 because we're moving only one lag. It's one value in the past. All right. So the basic concept here is established so you guys can understand now, I'm sure. We are going to move a little bit to the advanced part. We are going to do the VAR 2. All right, let's go. Hope you guys enjoy this. The VAR, it's not an easy model to deal with, but once you understand the basic concept, everything starts to make sense. All right. Make sure the board is clean. Okay. So now we are dealing with VAR 2. So if you understood a little bit how VAR 1 works, VAR 2 should be pretty much easy to figure out. But I'm going to show you. So VAR 2 here means that we're moving two lags in the past. So we base our regression two lags in the past to try to predict in the next 2 weeks, 2 months, or 2 years, or whatever. That being said, we still use apple and oranges. So apple is y1, oranges y2. So here we have y1t as usual, y2t equal beta 01, beta 02 plus beta 11, beta 21, y1t minus 1, y1t minus 1 also for the second. So I go simultaneously so you guys follow exactly. Whatever I write on the first equation, I always write it on the second equation too. So it's easier for everyone to follow. Plus beta 12, y2t minus 1, beta 22, y2t minus 1. All right. Now, since this is, you guys remember, this is VAR 1. But since we're moving two lags forward, backward, sorry, what we're going to do, we're going to put the t minus 2. We're going to write it that way. Beta 11, 2. All right. Beta 11, 2. y1t minus 2. Beta 21, 2. y1t minus 2. All right. That being said, I have to make a move back and come to beta 11 and beta 21, beta 12 and beta 22. So we are going to put a comma here and then put 1. Okay? All right. So you have here beta 11 comma 1. It means the 1 means that it deals with t minus 1. It deals with the first lag. So let me emphasize that here. So it means that this deals with the first lag. So you have here 12 comma 1, 21 comma 1, and 22 comma 1. So we are dealing here with the first lag. That's what it's about. Okay, so we keep going here. Plus beta, beta 12 2 times 1 2t minus 2, beta 22 comma 2 times 1 y 2t minus 2 plus epsilon 1 t plus epsilon 2t. This is the Vector Autoregressive Model 2. And then as you see here, this deals with T2. So I hope you guys see why it's written like this. So of course we have to put this into a matrix form and then write the model into a compact form. All right? So that being said, we follow the same process, guys. Y1t, Y2t. That doesn't change. Beta 01, beta 02, that doesn't change. What is going to change here is how we're going to group our coefficients and how we're going to group our predictors. Plus, all right, so beta 11 comma 1, beta 12 comma 1, beta 11 comma 2, beta 12 comma 2, beta 21 comma 1, beta 22 comma 2, comma 1, sorry guys. Oops. Beta 21 comma 2 and beta 22 comma 2. Yes, I draw a little bit too far this row. This one here. All right, we grouped our coefficients together. Now we're going to group our variables together. So we have here y1t minus 1, y2t minus 1, y1t minus 2, y2t minus 2, plus the epsilon 1t and epsilon 2t. This is the matrix form of excuse me, of the VAR2, and we can always do the multiplication to make sure that everything match. So just a quick trick here, guys. When you write the matrix form specifically for the variables, try to group the t's together. So put all the t minus 1 together first and then the t minus 2 together first. Don't try to put for instance y1t1 y1t minus 1 then y1t minus 2. No, don't do that. You might confuse yourself. Always put the t minus 1 together and the 2 minus t together. All right, so let's proceed with the multiplication here. y1t minus 1 times beta 11 comma 1. That's what we have. That's what we have here. Then y1t minus 1 times beta 21 comma 1. That's what we have here. Okay, y2t minus 1 times beta 12 comma 1, that's what we have here. y2t minus 1 times beta 22 comma 1, that's what we have here. All right, now we're moving to the second lag. y1t minus 2 times beta 11 comma 2, that's what we have here. Okay, y1t minus 2 times beta 21 comma 2, that's what we have here. And then y2t minus 2 times beta 12 comma 2, so this one, that's what we have here. And then y2t minus 2 times beta 22 comma 2, that's what we have here. So this is the Vector Autoregressive Model 2. And let me write the compact form now for the same process. Big yt equals beta t plus beta yt minus 2 plus epsilon t. And here we have t minus 2 because we know that we are dealing with two lags, like two lags in the past. So that's why we have this. So this is the VAR 2, Vector Autoregressive Model 2. All right, guys, I could end it here, but it won't be fun if I don't show you probably the longest equation you will ever see in your life. So what I'm gonna try to do here is to show you a VAR 3 with 3 predictors. It's going to be interesting. VAR 3 with 3 predictors. All right. So the third outcome variable here, let's say it's lemons. Okay, so apple, oranges, and lemon. So y1 remains your apple. y1t, y2t, and y3t. Okay, but we're dealing with 3 predictors, so the same concept applies, it's just that the equation would be longer. So beta 01, beta 02, beta 03. Okay, plus, plus, plus. Okay, now we start, we're going to group all the all the predictors that goes with the first predictor. So all the coefficients that go with the first predictor, that's what I meant to say. All the coefficients that go with the first predictor, which is t minus 1. So we're going to have beta 11 comma 1 times y 1t minus 1 plus beta 12 comma 1 times y 2t minus 1 plus beta 13 comma 1 times y 3t minus 1. We finished already with the first excuse me, we already finished with the first predictor. We're now moving to the second one. So we just writing the same here, beta 11 2 times y 1t minus 2 plus beta 12 2 times y 2t minus 2. I have to make sure I don't get confused myself. And then beta 13 2 times y 3t minus 2 plus, now we finish the second, we just finished here this grouping all all the coefficients for the second predictor. Now we're moving to the third one. Beta 11,3 times y1t minus 3 plus beta 12,3 times y2t minus 3 plus beta 13,3 times y3t minus 3 plus epsilon 1t. Okay, this is just for the first one, and we have to do the same for the second and the third. Let's go. All right, actually I'm gonna try to squeeze the pluses a little bit so that I have more space. All right, beta 21,1 y1t minus 1 plus beta 22,1 times y2t minus 1 plus beta 23,1 times y3t minus 1. We finished grouping everything, all the coefficients in the for the first predictor. We move to the second one. Beta 21,2 times y1t minus 2 plus beta 22,2 times y2t minus 2 plus beta 23,2 times y3t minus 2 plus, we finish now grouping everything, all the coefficients for the second predictor. Now we're moving to the third part, third predictor of the second equation. Beta 21,3 times y1t minus 3 plus beta 22,3 times y2t minus 3 plus beta 23,3 times y3t minus 3 plus epsilon 2t. And then now we're doing the last one. Beta 31,1 times y1t minus 1 plus beta 32,1 times y2t minus 1 plus beta 33,1 times y3t minus 1. We finish grouping, of course, the coefficients, all the coefficients for the first predictor, which is t minus 1. So now we're moving to the second one. Beta 31,2 times y1t minus 2 plus beta 32,2 times y2t minus 2 plus beta 33,2 times y3t minus 2. We finish grouping all the coefficients for the second predictor. Now we're moving to the third predictor set. And then beta 31,3 times y1t minus 3 plus beta 32,3 times times y2t minus 3 and then beta 33,3 times y3t minus 3 plus epsilon 3t. Yes, people, this is the whole equation you have here. And then we have to write that into a matrix form. How are we going to write that into a matrix form? The same process applies again. It becomes really easy. y1t, y2t, y3t equal beta 01, beta 02, beta 03 plus, that's where it's going to be interesting, beta 11 1, 1, beta 12 1, 1, beta 13 1, 1, beta 11, 2, beta 12, 2, beta 13, 2, beta 11, 3, beta 12, 3, beta 13, 3. All right. Now I have an idea, as you can see here. And then we do the same for the second row. Beta 22, 1, beta 20. Oops, sorry, it's beta 21, 1 first. Sorry, guys. My brain is getting fried. Okay, beta 21, 1, beta 22, 1, beta 23, 1, beta 21, 2, beta 22, 2, beta 23, 2, beta 21, 3, beta 22, 3, beta 23, 3. Then we have here beta 31, 1, beta 32, 1, beta 33, 1, beta 31, 2, beta 30, beta 32, 2, beta 33, 2, beta 31, 3, beta 32, 3, and beta 33, 3. And then we have to put all the predictors together. So we have y1t minus 1, y2t minus 1, y3t minus 1, y1t minus 2, y2t minus 2, y3t minus 3, y3t minus 2. And then, okay, y1t minus 3, y2t minus 3, and y3t minus 3. Plus, you have your epsilon 1t, epsilon 2t, and epsilon 3t. All right, guys, do I really need to go over the multiplication of everything? I think you guys got the idea at this point. But let's write it into a matrix, into a compact form now that we develop the matrix part. So it's going to be y t plus equals beta t plus beta yt minus 3 plus epsilon t. And this is the VAR 3. This is the VAR 3 with 3 outcome variables. All right, that's it, guys. This is the longest video I've ever made since I'm on YouTube. It's 44 minutes it's been going on, but now you guys have an idea of what the vector autoregressive is about. So this is very advanced. You will see people work at banks, hedge funds, mutual funds, any financial organization. They use this model every day. They even do more complicated stuff than that. So I decided to do manually so that you guys will see the calculations that go behind it. But at the end of the day, in the professional world, you're not going to do this manually. The computer will do it for you. But I want you guys to understand the mechanism behind it and what it takes to get it done. So I hope you guys really enjoyed this video. Let me know in the comment what you think. And let me know if you want a video similar to that about a time series model, or go back to cross-sectional data such as the logistic regression or the exponential regression. It depends. I mean, let me know in the comment what you think, and then I will think of something to make in econometrics again. Until then, see you guys very soon. Thanks for watching.